Hello, I'm Cadet Casey Komar, class of 2022, and today I'm going to be giving an additional instruction video over matrix transformation. So first, before I begin into talking about matrix transformation, I'm going to go over a brief overview of matrix multiplication. So as you remember, matrix multiplication goes row by column, row by column. For matrix multiplication to occur, the number of rows in the second matrix must equal the number of columns in the first matrix. So as you can see here, when you multiply matrix A by vector x, you see A times x plus B times y, as shown over here in the resultant vector. And here, since the number of columns in the first matrix match the number of rows in the second matrix, we know we're good to go. So the resultant matrix has the number of rows in the first matrix, the number of columns in the second matrix, as noted here. So now that we've overviewed matrix multiplication, let's go into transformation matrices. So we'll often see these when we're going over how to transform vectors in the MA103 curriculum. Four main types of transformations you'll see is reflection across the x-axis, which is shown by the vector or matrix 1, 0, 0, negative 1. Reflection across the y-axis, which is shown by the matrix negative 1, 0, 0, 1. Reflection across the line y equals x, as shown by the matrix 0, 1, 1, 0. And then reflection across the x and y-axis, as shown by the matrix negative 1, 0, 0, negative 1. All right, now we're ready for our first problem. So problem 1, transform vector 3, 2 across the x-axis. Here we have our sample problem, vector 3, 2. So since we're transforming across the x-axis, we're going to need to use the transformation matrix 1, 0, 0, negative 1. And this is a 2 by 2 matrix. So let's do our quick check here. Columns and rows match up. So we know our result will have 2 rows and 1 column. So let's do the multiplication here. We have 1 times 3 is 3, 0 times 2 is 0, 0 times 3 is 0, and negative 1 times 2 is negative 2. So when we add these together, we get our resultant 3, negative 2. So if we put this on a graph here, we'll go over 3, down 2. Let's plot our point, draw our vector, and look at that. It's a reflection across the x-axis. Now onto a more difficult problem. So problem 2, transform vector 3, 2 across the y-axis and then across the line y equals x. So this is a 2-step transformation problem. So when doing a 2-step, you want to start with the first step closer to the vector that's being transformed, and then the second step further away, so that way you go in order. So first we want to transform across the y-axis. So we'll use our matrix negative 1, 0, 0, 1, and then we'll transform across the line y equals x, as shown by the matrix 0, 1, 1, 0. So when we're doing this, first we're going to break this up. We're going to do the transformation across the y-axis involving these two, and then we're going to carry across the transformation across the line y equals x over to here. So carry across, and then let's do this math real quick. Negative 1 times 3 is negative 3, and then 1 times 2 is 2. So when we plot that, we get over negative 3, 2. Draw our vector, and then we have a reflection across the y-axis. So then we're going to do multiplication for transforming across the line y equals x. So 0 times negative 3 is 0, 1 times 2 is 2, 1 times negative 3 is negative 3, and 0 times 2 is 0. So now when we plot this, we go over 2, down negative 3. Plot our point. And there we go. We have this vector reflected across the y-axis, and then again across the line x equals y.